So in this last problem in section 2.3, we're given this revenue function, and we're told that the revenue in millions of dollars realized by a social networking site is modeled by this expression right here. So, and what is X? That's the number of years since the beginning of 2007. So when X is 0, the revenue is 0 back in 2007, right? If you put 0 in here, you get zeros. So right at the beginning, the revenue is 0. So we are asked to find R prime of 3. What we want to do is, let me write that down, find R prime of 3. So the first thing we need to do is to get the derivative. So let's get the derivative of this revenue function. So R prime of X is, all right, we know how to do this. Bring the exponent down as a multiplier and decrease it by 1. So I'll just go through it. We'll get negative 4x cubed plus, now you bring this 3 down as a multiplier, 3 times 11, 33, and then decrease the exponent by 1, 2, and then minus, bring that 2 down, 72x, and now we've got just this linear over here, and we're just going to get its coefficient, plus 45. So we've got the derivative of the revenue function, and while we're here, let's go ahead and get the second derivative. So R double prime of X is, how about negative 12x squared plus 66x minus 72, and that 45 is a constant, the derivative is 0. So here's our two derivatives, first and second. Now let's compute R prime of 3. So R prime of 3 is going to be, now I'm just going to put 3 back into R prime. Here's R prime, so I'm going to put 3 in for all of these x's here, but you knew that. So it's going to be negative 4 times 3 cubed plus 33 times 3 squared minus 72 times 3 plus 45. Now I'm going to get my calculator and do this. So R prime of 3 turns out to be, when I compute that, I'm getting 18. Now let's do the same thing for R double prime of 3. So I'll put 3, take that 3, put it into R double prime. So here's what it'll look like. Let's go ahead and see what it looks like. It looks like this. Negative 12 times 3 squared plus 66 times 3 minus 72. So I'm getting R double prime of 3 to be 27. So let's just look at what we've got now. So the first derivative, I'm going to come back up here. My first derivative and second derivative. The first derivative is positive. The second derivative is positive. So I'll analyze that right up here. So first derivative is positive. That tells me that the function's increasing. Second derivative is positive. Tells me that the slopes of the lines are increasing. Multiply two positives together, you get a positive. So I think we need to say here that we've got a function that is, increasing at an increasing rate.